Assalamualaikum warahmatullahi wabarakatuh. My name is Zakwan Zulkarnain bin Zafani, and here is my friend
Muhammad Fitri bin Farid Zaman.
And today we'll be making a video presentation for our mini project assessment for subject programming for engineers. And our mini project assessment title is Smart Batch Production Tracker, and I will be introduced for the introduction. Okay, so the introduction is for SCADA and automation. So what is SCADA? So SCADA is stand for Supervisory Control and Data Acquisition, or for System Monitor and Control Transportation. So we'll be creating a company, which is our company, me and Fitri. So our name of our company is ZNF Systems Sdn Bhd. Is a Malaysian automation and digital manufacturing companies. So for more about our company, my friend here, Muhammad Fitri, will be explaining about our company profile. Yeah.
Okay, so this is company profile ZNF Systems Sdn Bhd. So about the company, ZNF Systems Sdn Bhd is developing intelligent real-time database management for Malaysia, production and manufacturing sector. And then the solution, the smart batch production tracker will in C++, Lex, operator and supervisor monitor warehouse database, check raw material level and track quality, control metric in one, automate flow, reducing manual data login and improving reliability. So next, system flowchart. The system flowchart outline the overall architecture of the smart batch production tracker, showing how operator interact with the warehouse, database, raw material, inventory and quality control metric through a unified automate flow. It illustrates the pathways from login, how then notification through to batch processing and system layout, reflecting a real world manufacturing environment where use can check component availability, update inventory and evaluate production yield metric. Okay, so next the slide, Zakwan will continue the program flowchart.
Okay, so I will be continuing about the program flowchart. So for the program flowchart details the step-by-step logging implemented in C++, covering logging authentication maximum of 3 attempts. So I will zoom for in our program flowchart, which is there will be a starting part for the first, which for the start. Then after, it will be in a large global valuable stock, which is where I put 500 the value. So we need to log in the workers ID and password. So if it will be valid, it will be moved to the other slide. So what will happen if it was invalid? So the system will log and wait for the input, or it will be just end. So that's mean if you don't have the ID and the password, we will not able to move into our next interface. So what happened if it was a valid password and ID, workers ID? So it will display factory control dashboard, which is our raw materials, our QC, which is if it was passed or it was failed. So it will, after the inventory, it will be showing the new inventory. So from our past production. So here is our C++ source code. For our C++ code, there will be a lot to explain here, but for the login, workers ID and password, authentic maps of 3 attempts, like I said, and for this display dashboard, it will show raw materials, finished good, and scrap for the scrap count. So for the progress batch, it will validate stock progress batch and simulate 70% past yield products. So for the main, it will be control login, menu loops, and system shutdowns for the last version. So for the system output screen here, I will be passed down to Muhammad Fitri for explaining a little bit about our system output screen. So here we go.
Okay, from the result system output screen, for the first one is login screen, grade the user and prompt for worker ID and password. A maximum to login the login screen is
3 login attempt.
3 login attempt is allowed to ensure system security. And the second is main menu. After the login, after the successful to login login screen, user can view raw material, finisher good, scrap, or reject count, or is it the program. And then for the batch processing, enter quantity for a new production batch. The system display update raw material balance, finish good unit, and scrap or reject unit. And then choose option 2 to end the program. Okay, next I will pass to Zakwan Zulkarnain to explain about financial budget.
Okay, so I'll be explaining for our financial budget estimated for our ZNF system Sdn Bhd. So our project budget overview, the financial budget estimate outlines the project cost associated with developing for our development for the smart batch production tracker. So I will zoom. So the final cost of the ZNF is RM62,850 ringgit. So the financial budget estimate outline the project cost associated with developing the smart batch production tracker. So this budget support the business case for implementing the tracking solution in Malaysia production and manufacturing sectors. From a business perspective, using tracking system mean less manual counting, fewer data entry mistake, and more efficiency operation through a real-time visibility, contributing to a strong return of investment (ROI) for our company ZNF Sdn Bhd, system Sdn Bhd. So next is our conclusion and reference. This is our last part. So the smart production for the smart batch production tracker demonstrate how C++ can power real-time warehouse and factory management, reducing manual counting, minimizing data error, and enabling live production visibility. It's applied OOP loop function and sedar principle for our project, showcasing the potential of digital automation in Malaysia manufacturing. So in that so this is our reference, which is inductive automation 2024, Siemens AG 2025, and Mr. Boyce W 2023, which is our reference for our project, which is we studied these books and their companies to ensure our project here establish and go with the new environment of Sedar project. So I think that's all from me and Fitri. Thank you.
Thank you.